Hello, my amazing college algebra students. This is Mrs. A, and I love math. So, I had one of my students ask me if there was a way that I could make a video to show how we could tell if a set of points formed a triangle that was a right triangle. And I know why this student asked this question, because it's a very good question and it's probably going to be on your test. So we're getting ready for a test this coming Monday, and so I hope you will watch this video and see how to do this. Now, I did not use the same problem that we had done before, the one that the student had a question on, because I couldn't find that specific problem. So I've got another set of points, which I got out of the review section on your book. And I'm going to find the distances. So I labeled the point ABC so that we could tell the difference between them. And remember, when we're talking about a right triangle will hold the Pythagorean theorem will be true for a right triangle. And remember, the Pythagorean theorem is a squared plus b squared equals c squared, which means that the sum of the shorter sides squared, each one of the shorter sides squared and then added together will equal the hypotenuse squared. So I started this for you just so that you could see how we do it. Remember, the distance formula is down here at the bottom. The distance between 2 points is going to be the difference in the x values squared. And since we're squaring it, doesn't really matter which way we subtract them, does it? And so plus the difference in the y values squared and the square root of that whole thing. Okay, so here we go. We did the first one, so AB is going to be AB. So I just said -4 minus 6, which is the difference in the two x's, and I squared that quantity. And then 5 minus 1 is 4, and I squared that quantity, and then I simplified. -4 minus 6 is going to be a -10, so that's a -10 squared. And then that's a 4, and so that's a 4 squared. And so then we have the -10 squared is a 100, and then the 4 squared is a 16, and 100 plus 16 is 116. So we have a square root of 116. If all you are doing is trying to figure out if it is a right triangle or not, you really don't have to go ahead and simplify that. However, if your instruction was to find each distance, which is probably the way it's going to be on your test, find each distance and tell whether it's a right triangle, then you would need to find your distances in their simplest form. Okay, so we'll talk about that more in just a minute, because I need a little bit more board space to show you what each one of those simplifies to. So we did the second distance, BC, and here's B and here's C. So 6 minus a -8 is going to be a 14, and we're going to square it. And 1 minus a -5 is going to be a 6, and we're going to square it. Okay, so we end up having the square root of 14 squared, which is 196, and added to 36, which is 6 squared, and 196 plus 36 is 232, and the square root of all of that. So we found the two sides. I did that before I turned on the video because I didn't want to bore you to death. So I'm going to do the third one with you. So here we're doing CA. So I'm just going to take this one minus this one, my two x values. So I'm going to put my parenthesis here and put -8 minus a -4. So -8 minus a -4. Oops, that's a minus a negative. And we're going to square it and then add it to -5 minus 5. So -5 minus 5, and we're going to square that. So when we simplify this one, -8 plus 4 is going to be -4 squared is going to give me the 16. And then -5 minus another 5 is -10 squared is going to be 100. So we have another 116, don't we? So we have a 116 square root again, and that was between the C and the A. Okay, so we have square root of 116, square root of 232, square root of 116. So now I'm going to show you the graph of the triangle. Okay, and we're going to make this long side here, which is the only, this one is the only one that looks like it could be right. Okay, so we're going to make these two shorter sides the square root of 116, and we'll make this one over here the square root of 116, and we'll make this one down here the square root of 232. Okay, so now we're going to get another board, and on this board we're going to find out if we have our Pythagorean theorem true. So here's my Pythagorean theorem. A squared plus b squared equals c squared, where c is always my longest side, my hypotenuse. Okay, so we're going to say A, remember we had square root of 16, square root of 116, square root of 116, and square root of 232 were our sides. So when we square the square root, don't we just get 116? So we square the square root, we get 116. We square the square root, we get 116. And we square the square root, and we get 232. So we say, is 116 plus 116 equal to 232? And the answer is, yes, it is. So since my Pythagorean theorem is true for these points and their distances, I will say, yes, this is a right triangle. Okay, so now what we're going to do, now that we've decided that yes, it is a right triangle, we're now going to say, how do I find the area of that right triangle? So I'm going to go back here to this picture. So now that we have decided that it is indeed a right triangle, then we know this is right. And since a right angle, the right triangle, it's oriented in a way that doesn't make this easy. But if I had it oriented this way, to where this was the height and this was the right triangle, then couldn't I use this side as my height and this side as my base? Because I have a right triangle, it's going straight up. So isn't this side the height and this side the base? So I'm going to remember that my formula is 1/2 base times height, and I'm going to turn the triangle around in my brain to where it's sitting in this direction. So I'm going to use the two sides that are touching the right angle, and they are both square root of 116. So let's do that on another board. Okay, so here is another board, which I will clean up here. So now when we're talking about the area is 1/2 base times height, because we're talking about the two legs of the triangle, not the hypotenuse, will be my base and my height. I'll say 1/2 square root of 116 times the square root of 116. Okay, now look at this. Isn't this just the square root squared? Because I've got it down twice. Therefore, the square root squared is going to end up being 116. And 116 cut in half is going to end up being 58. So the area of the triangle is 58 square units. Okay, whatever the units were. Now, the last thing I want to show you here, one more board, is how to simplify those sides. Because when we're talking about the distances, remember the distances were square root of 116 and square root of 116 and square root of 232. And if I were asked to tell the distances, I wouldn't leave them in that form. So what I'm going to do is I'm only going to do the 116 once. okay, because I don't need to do it twice. But we need to simplify these two radicals to get them in their simplest form. So the one thing I want to do is I want to look at what is 1/16 divisible by. So if I divide by 4, okay, I know my divisibility rules tell me that if the last two digits are divisible by 4, the whole number is divisible by 4. So I'm going to pull out a 4, and when I do, 4 goes into 11 two times, and then I have a 36 left over. 3 and then a 6 is 36, and 4 goes into 36 9 times. So 116 is 4 times 29. So I would take the square root of 116 and I would break it into the product of two square roots, like that. And then I would say, well, the square root of 4 is 2. And so my final simplification would be 2. Let's see if I can squeeze it on here. 2 onto the square root of 29. Barely fits, but 2 times the square root of 29 is that one simplified. Now, I know that this one is also divisible by 4 because I can see the 32 is divisible by 4. So I'm going to take 232 and I'm going to divide it by 4. Okay, and that's going to go 5 times, and that's going to leave me with a 20. So 32 left over. 4 into 32 is 8. Okay, now 58 is divisible by 2, but it is not divisible by 4 again. Okay, in fact, if I did divide it by 2, I would get a 29 again. So 29. So this one is 4 times 2 times 29. So now we're going to end up, since 2 and 29 are both prime numbers, then the only thing we can pull out is the 4. So we're going to break this square root of 232 into the square root of 4 times the square root of 58, which when we simplify is just going to be 2 square root of 58. 2 onto the square root of 58, and those would be simplified radical forms. 2 square root of 29 and 2 square root of 58. So I hope that that answered your questions on how to, 1, find the distances of the sides, okay, and 2, how to tell if it's a right triangle, and 3, how to find the area of that right triangle. And I think that covers it. This is Mrs. A. May God bless your day.